Today we are going to solve Cambridge IGCSE paper 6, which is alternate to practical, and the paper code is 0625/63, and it's a May June 2023 paper. So let's start off with our first question, and the first question is regarding principle of moments. So let's start off with that question, and it states that a student determines the mass MR of a meter ruler by a balancing method. He uses the apparatus shown in the figure 1.1. So you can see there is a meter rule placed over here, and then we have a bench, a pivot, and this is your load, and we have a 5 centimeter marker over here, 50 centimeter marker is over here. The student places a circular load of mass m 20 grams on the meter rule, but in a position different from that shown in figure 1.1. Determine the distance d naught of the center of the load from the zero and the ruler as shown in figure 1.1, and figure 1.1 is not to scale. Okay, so first of all, what you need to do is you can see there is a line that is say 6, and this is your 9. So if you subtract 6, I mean, it's going to be, you need to find out the center, you don't need to subtract. It's basically you are going to add 9 plus 6 divided by 2. This will give you 7.5 centimeter. Or you can do this thing, the middle point of 9 and 6 is going to be 7.5 centimeters. So this is what you need to write it down. So unit are already mentioned, no need to write it down. Moving to the next question, the student places the meter ruler on the pivot and changes the position of the load so that the center of the load is at 5 centimeter mark. He adjusts the position of the meter ruler on the pivot until the meter ruler is as near as possible to be balanced. Describe a technique for ensuring that the ruler is as near as possible to being balanced. So the answer for this is this: you simply have to move the ruler to find the point at which it tips in one direction. So this is what you need to write down in this answer. Okay, moving to the next question. The student determines the scale reading P on the ruler of the position of the pivot. He calculates the distance between 5 centimeter mark and the pivot, and the distance B between 50 centimeter mark and the pivot using the equation this. Okay, so now what you need to do is a is equals to p minus 5, b is equals to 50 minus p. He repeats the procedure for the value m equals to 40, 60, 80 and 100 grams. His results are shown in the table. For the value of m 20 grams, calculate and record in table 1.1 the value of b. Okay, so how you're going to find out the value of b over a? So simply you have to divide b 5.5. I'll write it down over here, divided by 39.5. So these are the decimal points, so it's going to be 0.1392, which is approximately 0.14. So mostly you can see this thing, see all answers are in two significant figures. So I have again converted the number into two significant figures as well. Okay, in the next part, you have to plot a graph of m, which is mass in grams, and on y-axis, and against b over a on x-axis. So if you draw this again by using those values, so it's going to be m is going to be over here, the unit is going to be here, b over a, this is on the x-axis. So you have to take the values from this table. So this is going to be on y-axis, these values, and these values are going to be on your x-axis. So you have to label these. So if you draw these graphs over here, so again it's going to be somewhat like this. The values would be somewhat like this. So you can see the line which you have to, again a best fit line you have to draw, which means the equal number of points above and below the line. So this is how you can do this thing. If you want to label it this is going to be 20, this is going to be 40, 60, 80, and over here you can do this thing 0.14, this is going to be 0.28, this is 0.42, this is going to be 0.56. So this is how you can easily draw this. Determine the value determine the gradient g of the graph. Show clearly on the graph how you obtain the necessary information. Again, what you need to do is, if you draw the graph, so basically you have to take 2 points, and the values for this is going to be 0.50 and 83, and the points over here is going to be 0.14 comma 20. So now you can easily take the gradient, which is, or slope, that is going to be delta y over delta x. So it's going to be 83 minus 20 over 0.50 minus 0.14. So you will get the answer 150. Okay, the mass MR of the meter rule is numerically equal to G. Write down the value of MR in the experiment, include the unit. So over here, the mass MR of the meter is numerically equals to G. So what you can easily do is, it's already saying that this mass is equals to G. So G, value of G is this. So obviously it's going to be 150 grams. So again, this is mass, so you need to put the units. Okay, the determination of MR by this method assumes that the center of mass of the meter rule is at 50 centimeter mark. Suggest how you could use the apparatus from figure 1.1 to test whether the center of mass of the meter rule is at 50 centimeter mark. You may draw the diagram. Okay. Uh, First thing is this, that if it is on a 50 centimeter mark, so we are going to be looking at this, that the rod is at balance state, or you can say the rod is at okay, balance the rod on pivot. So that will tell you whether it is in equilibrium or not, or you can do this thing, clockwise movement is equals to anti-clockwise moments, or basically what you can do is this is what you need to do, is to see the rod is balanced or not at 50 centimeter marker. A student finds that the center of mass of her meter rule is at 48.7 centimeter mark. Suggest how she changed the procedure B in B2 to allow this. So, how she is going to allow this, which is 48.7. So, let me check. B2 is going to be B2. Yep, this is the one. So this is, you need to see is equals to this. Okay, so over here what you need to do is, you have to change this value, this equation, and over here what you need to do is, simply you have to do this thing, like it was B is equals to 50.0 minus P, and then you have to change that thing into 48.7 minus P. So this is how you are going to do it, and you can do this from table 1.1 as well, from table 1.1. A student investigates a circuit containing different combination of resistors. She uses circuit A shown in figure 2.1. Circuit A is not yet complete. And on the figure 2.1, complete the circuit to show a voltmeter connected to measure the potential difference across resistor U. So if you want to measure the voltage across resistor U, so you need to add voltmeter always in parallel, always in parallel. Okay, circuit A, the student measures the potential difference V across the resistor U and the current I in the circuit. So over here we have to record these readings. So in the circuit, for circuit A, the voltage is, if you see this thing, this is 1.7 volts, and this is what we have to write over here. So and in this, the current is approximately 0.42. So I will be writing 0.42 over here. Now we know that from the Ohm's law, V is equals to IR, and we need to find out resistance. So V divided by I is equals to R, and that is going to be 1.7 divided by 0.42, which will give you 4.05. And then similarly we have to again divide this by the 2.1 divided by 0.54. This is going to be 3.89. 2.4 divided by 0.63. This is going to be 3.81. Again, these all values are in three significant figures, so we have to change them. So we are going to change these values into, this is going to be 4.1, this is going to be 3.9, and the last one is going to be 3.9, but it's going to be 3.8 because this number is less than 5. So these are the values which are in two significant figures. So these are the values we are going to replace these with this numbers. Okay, circuit B is this one, in which you have two parallel resistors of 3 ohms. Circuit C is the one with the 3 ohms, 3 parallel resistors. The students connects two 3 ohm resistors in parallel between P, Q as shown in figure 2.4 from the to form circuit B. The student connects three resistors in parallel as shown in figure 2.5 to form circuit C. For each circuit, she measures the potential difference V across the resistor U and the current I in the circuit. Her readings are shown in table 2.1. Calculate and record 2.1 resistance of the U for each combination of this. Use the reading from this. This is what we have already done over here. So this is we have done over here. The answer for that question is this one. Okay, a student suggests that the value of R should be same. Value of R should be same. Suggest whether your results suppose the suggestion. Justify your statement by reference to values from your result. Okay, so how you are going to check this? This is going to be checked by these values. Yes, so this is, you can see that then they are close to each other. So yes, the suggestion is correct, or you can say he is right. And justification, because it is within the limit of experimental accuracy. A student determines the resistance of resistor U using a variable resistor to control the current in the circuit. Complete the circuits in figure 2.6 to show the variable resistor used for this purpose. So the symbol for variable resistor is going to be like this. So this is your variable resistor. Briefly explain one advantage of using variable resistor to determine the resistance of resistor U rather than procedure carried out in B and C. It's going to be easy to perform in a sense that you can control the amount of amount of current, because when you increase the resistance the current will decrease, and you can change current as required. A student suggests that the potential difference and the current for resistor U are proportional. Okay, that potential difference and current, this is basically the Ohm's law, which in which you have this graph voltage and current. So this is directly proportional curve. State how graph of potential difference against the current of the resistor you can confirm this suggestion. So basically voltage is directly proportional to current. So if you get this type of graph, so this will tell you that it's uh, these are directly proportional, and again you can have a straight line as well in this graph. So if you got a straight line like this, OA line, then this means that you are on a right track, and this is they are proportional to each. A student investigates the reflection of light by two plane mirrors. The student's ray trace sheets is shown in figure full size in figure 3.1. Okay, so basically these are the two mirrors. EF and FG are two mirrors placed like this. If you see this thing, this is going to be like this. Let me draw a rough sketch, and this is going to be, these mirrors are placed like this. Okay, so these sketches are like this. Okay, there is P1, P2, P3, P4, P5, P6, and these are there is an angle over here. The student placed two mirrors FE and FG at an angle of 100 to each other as shown in figure 3.1. Okay, this is your FE, this is your FG, which is like these are the two mirrors and they are placed at an angle of 100 degrees. So this is your angle. This is the first line, it is saying this. On the figure 3.1, draw a normal FG at a point N and extend the normal below FG. Label the lower end of the normal with the letter L. Okay. Draw a normal FG at point N. So you can see this thing. This is your point N. So this is going to be your normal line. Okay, I'm using a freehand sketch diagram, so you can use a scale to make this thing. So this is your normal. Okay, normal line, and you have to label it as, okay, I'll be extended this L. So which is normal is basically 90 degrees to the boundary, is 90 degrees to the boundary. Okay, what else is there? Normal FG at a point and extend the normal below and label the lower end of the normal with letter and L. This is done. The students draw line AN as shown in figure 3.1. AN is this line. Yes, this is the line that he has drawn already. Okay, on the figure, measure the acute angle theta 1 between the lines AN and GN. AN and GN. Okay, so this is theta 1. So basically, we have to put our D or a protector over here, and then we are going to measure that thing. So it's going to be around, it's going to be 15 degree because you have to measure this thing. So it's going to be 15 degrees over here. The student places two pins P1 and P2 on the line AN, and as shown in the figure, measure the distance between P1 and P2. So again you have to use a scale and you have to measure the line between P1 and P2. So this line you need to measure it, and whatever the distance is you can easily put the value over here. So which is going to be around, as per the marking scheme, is 3.5 centimeter. So you can use the scale to do that. Okay, suggest whether the two pins are suitable distance apart for accurate ray tracing. Explain your answer. So again 3.5 is not a suitable answer, not a suitable distance I would call it, because it should be more than that as far as it could be, and explanation should be as far as possible. Okay, the student views the image of P1 and P2 in mirror FE. She places two pins P3, P4 so that pin P3, P4 and image P1, P2 all appears on a behind. Draw a line through P3 and P4. Extend the line 10 centimeter above FE. Above FE. So 10 centimeter above FE, and you need to uh, join this line P3 and P4. Just a second, let me zoom it out. This is going to be this line, and this is going to be 10 centimeter above FE. So I'll erase this, and 10 centimeter above. Let's suppose this is your 10 centimeter above. Okay, FE. This is the one task that you need to do. Then draw line P3 and P4, extend. Label the upper end of this line with R and label the lower line with B. So upper part is going to be R and the lower part is going to be the B. Okay, done. The student repeats the procedure for an angle theta 2 equals to 40 degree, and she places the two pins P5, P6 so that the pins P5, P6 and the images P1, P2 all appears one behind. Draw a line through P5 and P6. Extend the line until it crosses BR. Draw the line until it crosses the P5 and P6. So you have to draw the lines P5 and P6, P5 and P6 until it crosses the line BR. So this is basically you have to draw the line. Again I am drawing it with a free hand, so you need to use a scale to draw these lines like this. Okay, and this is done. Draw a line P5 and P6, extend this, label the upper end with T and C. So now we are going to label those lines with T, and this is going to be C. Okay, this is also done. Measure the acute angle. So now again you have to measure the acute angle alpha between the lines BR and CT. So basis BR is this one and CT is this one. So this is the angle you need to measure. So again use the protector to do this thing, and that is going to be 25 degrees as per the marking scheme. So I am going to be writing this 25 degrees. This the unit is already given over there, so no need to put that O at that point. Okay, so as per the marking scheme is 25 till 29. So if you got a 25 answer, it's also right. Okay, now moving ahead, a student thinks that there is a relationship between angle alpha and the value of theta 1. So theta 1 is what? Where is theta 1? Theta 1 is 15 degree. This is theta 1. And where is alpha? So this is this one 15 degrees. So state what your results suggest that relationship could be justify your answer. So what, so if you see alpha is 25 degrees and theta 1 is 15 degrees. Okay, so state what is this? Okay, what we can do is theta 2 minus theta 1, it is equals to alpha almost. Let me check. Okay, I'm sorry for that. I missed this part, and we are going to solve this right now. And this is going to be what the student repeats the procedure for angle theta 240. He places two pin P5, P6, P, and this all appears at the one behind the other. So this is going to be this angle. This is theta 1, and this is going to be your theta 2, which is going to be 40 degrees. So this is going to be your 40 degrees. So if you subtract 40 out of 15, so you will get 25, which is almost equal. Now our statement and our correct observation is correct for this question, which is going to be, let me write it down, matches the results, is going to be matches the result. This is theta 2, right? Okay, and what is this? Again, we are going to write it down, theta 2 minus theta 1, which is angle alpha, and again is matching the values or angle or results, values or angle. So it's up to you how you are going to write it. Suggest two procedures to take in this type of experiment to ensure accurate results. So first of all, again, you have to use sharp pencils. You can use the distance between the pens, between distance between the pens as far as possible, and then as you view the pens from bottom and draw thin lines. Okay, suggest one reason why different students all doing this experiment carefully may not obtain identical answers, because it is hard to align the pens, to align the pens. So that's why this is going to be a trickier one. Okay, moving to the next question. It's a 7 mark question, I think, and let me see. Yes, it is. So, a student investigates the rate of cooling of hot water in a container which has a lid. Plan experiment which enables him to compare the effect of lids of different thickness on the rate of cooling. The apparatus includes a beaker, a supply of hot water, insulating material, which lids can be cut. In your plan, you should list any additional apparatus needed. Explain how these this. Okay, let's do this thing. We will do these experiments. So before doing that, it's first of all we have to identify the independent variables which are going to be changed. So I would be writing independent variables which are going to be changed. So those are basically the thickness of the lids, because we have to find out the rate of cooling in hot water. Thickness of lids are going to be changed. Okay, so then we talk about the dependent variables, which is again we are going to record, and this is going to be what, you can see the rate of cooling, the time for cooling or you can do this thing rate of cooling. It's up to you how you are going to write it out. And then there we have a control variable which is going to be kept same constant, or those are going to be the volume of water. Okay, so first of all, list any additional apparatus needed. Okay, any additional apparatus which we are going to require is your stopwatch and thermometer. So basically these two instruments are not available, so we are going to write it down. Explain briefly how to do this experiment, including measurements to take so that the rate of cooling can be determined. Again, first of all, what you need to do is just memorize these steps. First of all, you measure, then you record, and in the last you repeat these values. So how you're going to measure in this measure, you have to measure the rate of cooling times through the stopwatch, and then rate of cooling time, rate of cooling, or you can say time. Let's suppose after 1 minute or after 5 minutes you're going to do this, and then you have to record the temperature, and temperature you are going to record, and you can do this, repeat this value, repeat by changing thickness of the lid, thickness of the lid. This is what you have to do in this experiment. This is done, this is done. State the key variables to be kept constant. So again, this is going to be the volume of liquid, volume of water, which we are not going to change, and initial temperature. Okay, this is also done. Draw a table or a tables with columns to show how the readings are going to be taken. So again, what we are going to do is thickness. This is going to be in centimeter. Okay, then we have, this is going to be our table. Then we are going to have time, which is in seconds, and then again we have initial temperature, which is going to be in degrees Celsius. Then we have to be like the final temperature, again it's going to be in degrees Celsius, and then we are to find out the change in temperature, which is again to be in Celsius, and this is going to be the table for this thing columns. And this, explain how to use the readings to reach to the conclusion. So once you have done this, you can easily plot a graph between thickness and the rate of cooling. Rate of cooling is on x-axis and thickness of the lid is on the y-axis. So this is how you do it. So now you can write this whole points, or write all these points in a paragraph, so that you can easily jot it down over there. So you guys can do this very well, I hope. Thank you very much. Take care. Bye bye.